All right, guys. The topic of the week has been high availability, right? I know a lot of it has to do with theory, but I want you guys to make sure you understand it. That's why we're going through it. Um, and of course, whenever you guys take the exam, shout out to Markivia because she'll be taking the exam next month. I just want you guys to be able to walk in the exam and not be scared to answer any questions about it. Okay. So let's go ahead and cover failover and workload. It's a hefty session, so it will take a while. So we're only going to cover that failover and workload tonight, and then tomorrow there will be no session because I do have a work event tomorrow night. But Friday night, um, if you guys would like, we can have the makeup session along with the Saturday session. Okay, but we can talk about that after this. Okay. All right, so
Sounds
let's
good.
let's go ahead and hop in. All right, so what are the different types of failover protection types, right? So let's start with device failover, right? So device failover, right? It's triggered when a primary FortiGate stops sending heartbeat traffic. You guys learned about that yesterday and this mostly this week, starting last Saturday, right? When of course the FortiGates and the clusters stop hearing heartbeat traffic, the secondaries renegotiate and select a new primary. That is a failover protection type. Okay. All right. Next, link failover. Right. Link failover occurs when the link status of a monitored interface on the primary FortiGate goes down. You can configure an HA cluster to monitor the link status of some interfaces. If a monitor interface on the primary FortiGate is unplugged or its link status goes down, a new primary FortiGate is elected. So it's similar to device failover, right? But if a monitored interface goes down, right, on the primary FortiGate, right, what the FortiGate is going to say is, you know what? Time to select a new primary FortiGate for the cluster. If you configured monitor ports, okay. So that's just taking it a step further at the layer one level. Okay. Next type of failover type is session pickup, right? So session failover, right? Um, and what that is, right? It's you enable it, right, for your traffic, right, for that type of traffic that you want to synchronize amongst cluster members, right? The sessions are resumed in the event of a device failover, right, or a link failover. Okay, one of the protection types, right? Okay, memory utilization failover, right? If you enable memory-based failover, right, an HA failover can be triggered when memory utilization exceeds the threshold for a specific amount of time. You can enable the memory-based failover through config, system HA, CLI command, right? Right. So there's different types of events, right? And I want you guys to keep it in your mind, and we'll dive deeper later in this session. That might trigger a HA failover, right? Such as hardware software failure in the primary FortiGate or an issue on one of the interfaces on the primary, right? Whenever a failover occurs, an event log is generated, right? And what you can do, right, has an extra step. You can go ahead and have the FortiGates, right, of the entire cluster, right, to generate a SNMP trap, right? Send it to the SNMP server, right, and shoot you over in an email. So of course Donovan will go ahead and know, hey, we had a failover event for our primary FortiGate within the cluster at our data center. Let's go ahead and get that replaced and worked on. Okay. Make sense so far, guys? All right, excellent. So, virtual MAC addresses and payload, right? To forward traffic correctly, right? A FortiGate HA solution uses virtual MAC addresses. Okay. All right. So when a primary joins an HA cluster, right, each interface is assigned a virtual MAC address. So I want you guys to lock that down in your notes because I'm going to make sure I ask you a question about that. Whenever a primary FortiGate joins an HA cluster, each interface is assigned a virtual MAC address. Okay. The HA group ID is used in the creation of the virtual MAC address assigned to each interface. right? So if you have two or more HA clusters, right, in the same broadcast domain, right, and using the same HA group ID, right, not saying you would configure it, but just in case, right, you might get MAC address conflicts, right? Right. And so for design purposes, right, if my Kiwi is deploying this, right, Fortinet, they recommend that you go ahead and assign different HA group IDs to each cluster. Okay. All right. But if we're using heartbeats, right, the primary, as you guys been learning, informs all the secondaries or the other FortiGates in the cluster about the assigned virtual MAC address, right? Upon failure, right? A secondary adopts the same virtual MAC address, right, for equivalent interfaces. Why is that important? Well, it's important because whenever we want to do session, right, session pickup, right, the other devices, right, maybe the switch that's connected to this cluster, they're not going to see it has there was an interruption because it's not their job to see if the FortiGate failed or not. We need to provide availability, right? So if you have a virtual MAC, they're sending it to a virtual MAC, and if that virtual MAC is shared amongst the cluster, right? To our end users, to our other network infrastructure devices, it is seen as up, okay? Using these virtual MAC addresses, okay? Now, we're gonna get a little bit technical, right? Right? New primary broadcast GARPs, right? They're sent out whenever a failover does happen, right? To go ahead and notify the network that a virtual MAC is reachable through a different switch port, right? So even though the virtual MAC, right, is it won't change, right? But a GARP still needs to happen, for, so that switches and other devices knows how to reach this FortiGate, right, at the interface level, okay, on the other device side, not on the FortiGate, but on maybe the switch, okay. So again, a GARP will be sent out saying, "Hey, here where you can reach me at, although I had a failure on another port." Okay, still using the same virtual MAC. What the switch on the other side will do, it'll say, "All right, excellent. This virtual MAC is now instead of being on port one, it's now we can see it on port five." Okay, and of course, just keep in mind the MAC address for the reserved HA management interface is not changed to the virtual MAC address. That's its own separate MAC address. Okay. So since that's a dedicated interface, it's going to go ahead and make sure it keeps its own original MAC address. Okay. So we talked about failure of a secondary FortiGate, right? You guys learned primary fails, a new primary is elected, right? But what happens if the secondary device that just became the primary device fails, right? Well, it depends on the HA mode, right? In an active passive cluster, right? The primary only updates its list of available secondary FortiGate devices, right? It also starts monitoring for the failed secondary, waiting for it to come online again. Okay. So in an active passive, right, we learn that the secondaries, right, it's not passing traffic, but it is listening, right? It is listening to see, hey, we're watching for heartbeats, making sure we're consistently getting heartbeats, right? And if we don't, if we stop getting heartbeats, we automatically become the primary. But the primary FortiGate is doing the same thing, right? It's listening to see for its list of secondaries, can I reach all my secondaries by shooting those heartbeat messages out my HA interface? If I don't, right, if I don't hear from a secondary, I have a failed secondary, and I'm going to go ahead and wait for it to come back online. Okay. Now, active, right? All secondaries are handling traffic, right? So what happens in the case of a failure of a secondary FortiGate, right? So the primary, right, we just talked about it, it's going to track, right, in the assigned sessions, right, for each secondary, right, do some load balancing, right? What the primary FortiGate cannot do. It must not only update its list of available secondary FortiGate devices, it must also reassign sessions from the failed FortiGate to a different secondary FortiGate. So if a secondary FortiGate in an active HA cluster fails, okay, what the primary FortiGate or the master needs to do, it needs to say, okay, excellent. Hey guys, everybody was handling traffic. We have a failed secondary or a failed slave. We're going to go ahead and move, right, some of these sessions to another, slave FortiGate, right? So we can go ahead and process that traffic, right? That's how failure of a second FortiGate operates, right? Within HA clusters, depending on the different HA modes. Okay, let's talk about workload, right? Self-explanatory, right? The workload is distributed, right, between roles depending on the HA mode, right? Active, passive, right? The primary receives and processes all the traffic. The secondary waits passively, right, for the primary FortiGate to fail. Okay, active, right? The primary receives all traffics and redirects some traffic to secondary devices. Okay, and to keep it simple, right? Workload is not distributed, right, in active passive mode, but in active mode it is. Okay. All right. Now here's where we're gonna go ahead and get tricky, right, and have some fun, right? So we're looking at this diagram, right? So we have a cluster, right? Active mode, right? It's distributing that traffic when of course the traffic is subject to proxy inspection, right? So what's happening, right? So let's look at the client, right? So the client, right? If we're tracking this traffic, let me go ahead and grab this. Yeah, I can use this color. The client, right here, what is it doing, right? It's sending that SYN packet, right? It's shooting that SYN packet up, right? Right. It's always going to be forwarded to the primary FortiGate, right? Okay, and it's going to, of course, use that. It's going to go ahead and use that virtual MAC address as a destination, right? So this is going to be that virtual MAC address that the client sees. Is going to send it there. Okay. Now, if the primary decides that the session is going to be inspected by a secondary, right? The primary then, right, because all the client did was send the SYN packet. What that primary FortiGate is going to do is going to forward that SYN, and let me go ahead and change colors. It's going to send that SYN packet to the secondary, right? And then the secondary will go ahead and do the inspection of that SYN packet, right? Right, and as you guys can see in the example, right, we can go ahead and see that, right, at the second packet right here, let me go ahead and erase so I can get some drawings out of here, right? If we're looking right here, right, that source MAC address, right, is the primary FortiGate. Destination, right, secondary physical MAC address, right, secondary port 1, okay? And what's going to happen is, right, it's going to be that frame, right, because it's at layer 2, that frame is going to go ahead and be forwarded using the physical MAC address, right, of the primary FortiGate internal interface, right, and send it, right, destination MAC address using the physical MAC address, not the virtual, the physical MAC address of the secondary internal interface of that FortiGate. Okay, and that's what you guys see at the second frame that passed through, right? Right. So next, go ahead and clear the drawings, right? The secondary FortiGate, right? It's going to go ahead and let me just get my pencil. There we go. Right. The secondary FortiGate, right? It's going to go ahead and start that session, right? Start that connection with the server, right? Because this is where we want to get to essentially, right? It's going to forward that SYN packet that went ahead and came, that came from client, that came from the client, right, on the left side, right? And so it's going to go ahead and send it, and it's going to send it out using its external interface, using that physical MAC address, right? So it's not using the virtual; it's still using the physical, right? It's going to send that out. It needs to get sent out, right? Okay. And that secondary also responds with a SYNAC, okay, to the client, right, at that same time, right? For which the source MAC address is the physical MAC address of the secondary FortiGate internal interface. So at that same time, boom, we're sending a SYNAC. So you guys see right here, we're shooting that up, okay? But now what happens, right? Now the client, right, it says, all right, excellent. I received the packet, right? I received the packet from the secondary. I'm going to go ahead and send an acknowledgement or ACK, right? Still going to forward it to the primary FortiGate, right? Using the virtual MAC address, right? And it's going to be up to the virtual, right? It's going to be up to the cluster, I'm sorry, the primary FortiGate within the cluster to go ahead and forward that traffic, right? Right. And what's it going to do is going to go ahead and shoot that over to the secondary, right? And there we have it, right? It's going to go ahead and send that ACK to that server. Okay. Let's go ahead and erase that. Any questions, guys? Okay. All right.
I have a question, David.
Yes, sir.
How does it get back?
Oh, that's the other slide. So, like
Okay.
I was, yeah. So, three-way handshake, right? So we got
Okay.
an ACK and ACK, right? So it's sending that traffic, right? So what we're seeing in this active flow, right? Where you guys are seeing that the primary FortiGate is assigning traffic flow to that secondary. Okay, it can communicate with that server directly, but it's saying, nah, secondary, you can go ahead and take care of it. And if I need to send it back, right, I'll go ahead and send it back to the client. But secondary, you take care of shooting this traffic to the server.
Okay.
Okay. All right. Excellent. So you guys learned about clustering, right? You know, learned about HA clustering, where each FortiGate device acts as its own right security domain, right? But what happens, right? We have an HA setup, right? But we have multiple VDOMs, right? What you can do is go ahead and configure virtual clusters, all right? So what is a virtual cluster, right? Virtual clusters, they allow you to have one device acting as the primary for one VDOM and has a secondary for a different VDOM, right? Each VDOM has a primary and a secondary FortiGate, right? Any device can act as the primary for some VDOMs and the secondary for other VDOMs. Similar to if you had two switches, right? And they're working, with each other, right? On a trunk, right? And one switch can be the root switch or the root bridge for some VLANs, and the other switch can be the root bridge for other VLANs. Okay, similar concept. Okay, now because traffic from different VDOMs uh, can go to different primary FortiGate devices, you can use virtual clustering to manually distribute your traffic between the two cluster devices and allow the failover mechanism for each VDOM between the two FortiGate devices. Now, I'm telling you right now, you do not need to know that in depth for the exam. So take a breath of fresh air, right? This is just something good to know. Probably the higher level FortiGate exams, the FortiGate 7, probably so. But you just need to know what FortiGate virtual clustering is. Okay? All right. We've talked about a full mesh before, right? And so at the beginning of this lesson, right, we went ahead and looked at simple HA topology, right? Simple, if we had different HA modes, we just built a simple topology, right? Now we're looking at a complex build out, right? let's go ahead and take a look at this robust solution, right? So the idea, right, is to go ahead and prevent any single point of failure with HA in general, right? Not only on the FortiGate devices, but also on, other network infrastructure devices. Okay. So you guys can see on the slide, right? We have two FortiGates. We have two switches on each side. Okay. Using two different interfaces, right? Four different interfaces on each FortiGate, right? Excluding the heartbeat interfaces. Okay. This is what we call a full mesh. Okay. So it's providing availability all throughout that network. And this is typically what most enterprises look like, right? You got your HA solution, you got your two FortiGates, but every switch at every level, at the distribution or core level, or access level, is intertwined and connected to each other, aka full mesh. Okay. Any questions?
So far.
Okay. Awesome. So we just finished this section. So, question one. An HA failover occurs when the link status of a monitored interface on the blank goes down. Is it A, primary FortiGate, or is it B, secondary FortiGate?
Primary.
Primary.
Okay. All right. Good one. Question two. You can configure virtual clustering between only blank FortiGate devices with multiple VDOMs in an active passive HA cluster. Is it A, 2, or is it B, 4? Remember the diagram.
4.
Remember the diagram. How many physical FortiGates did I have?
Oh, 2.
There we go.
4,
So,
6. Let me write that down.
Yes. So you can configure virtual clustering between only two FortiGate devices with multiple VDOMs in an active passive HA cluster. Please write that down.
You can only configure a virtual cluster with only 2 active FortiGates and active passive. Right?
HA cluster must consist of only 2 FortiGates for a virtual cluster.
Got it.
All good?
Yep.
All right. All right, guys. Good job. We're gonna like I said, we're off tomorrow, but if you guys are open to have a session on Friday, I'm open to do that. Or if you just want to wait till Saturday, more than happy to do so. So just let me know, okay?
Yeah, you can do Friday.
Okay, excellent. I'll see you guys then.
All right, thanks.
Later.
Bye.